So hi everyone, my name's Patrick, and today I'm here to talk to you about 4 different technologies in Arbitrum that we're working on. But before I begin, who at a high level has an understanding of how a rollup works? Raise your hand. Great, so not everyone, that's what I wanted. So what I've included as well is like a small 2-minute premiere on how does a rollup work. So you get a rough idea of the high level interaction, and then hopefully that will help you understand why the technology is important, or at least what we're working on. So first come first is the users. Like, who do we care about? So there's 3 agents in the protocol that we care about. The first is the user. It could be Alice. Alice wants to buy and sell NFTs. Maybe she has a moon cat. She just wants to go have fun on a blockchain. Then we have the sequencer, and the sequencer's job is to take the user's transactions, decide the final ordering, and then pass it on. Then the executor should pick up the transactions, execute the transactions, and then hopefully confirm that indeed Alice was able to buy or sell her wonderful mooncat. So let's go through step by step of what this interaction looks like. So we have Alice, we have the sequencer, and Alice wants to join the system. So Alice will get 1 coin deposited on the bridge that lives on Ethereum. She'll deposit her coin on the smart contract. Then within a few minutes, it will pop up on the rollup, and she'll have 1 coin on Arbitrum. Now, Bob comes along, hi Bob, and Alice wants to send 1 coin to Bob. So Alice will create a transaction, she'll sign the transaction, and she'll pass this to the sequencer. Sequencer will take the transaction, and they say, yep, that's a valid transaction. So what happens next? So the sequencer can tell Bob to say, Bob, you're going to receive 1 coin. But that's important. The sequencer can tell Bob, but cannot confirm to Bob that he'll get 1 coin. All the sequencer can do is order the transactions for execution. So now the sequencer waits around, listens to the users, picks up all the transactions, and then eventually decides, okay, I'm going to order these transactions for execution. And Arbitrum, in rollup mode, will post this to Ethereum directly to the bridge. But generally speaking, the sequencer's job is to pass this on. So it could be passed on off-chain as well. And so once the transactions are ordered, they're on Ethereum, they're on the bridge, they're on rollup mode, all the transaction data is there, they're ordered, but they're not yet executed. So the executor has to come along. The executor will pick up the ordered transactions, and as the name sort of implies, the executor will then execute the transactions. And I've got a wonderful 1990 animation of this, and that's how fast blockchains work as well. But anyway, they execute the transactions, and then eventually the executor will pose a checkpoint to the blockchain. And this checkpoint is really saying, given that list of transactions, once I've executed it, this is now what the database looks like. This is post-execution, this is the state of the smart contracts, and everyone's new balance. And that's how rollups work. They just continuously order transactions, they get ordered, and then someone comes along and they execute them. And they convince this smart contract on Ethereum called the bridge that this is indeed what the off-chain system looks like. Now, so that's how they work, but in Arbitrum and in most rollups, we all like to talk about fraud proofs or validity proofs. So where do they come in? And at least in Arbitrum, we have fraud proofs. So where do fraud proofs come in? Fraud proofs are really about making sure that that checkpoint is correct. What if the executor tried to cheat? And they say, well, this is what the transaction was supposed to do, but really the transaction gives me all the money. Well, that would suck, wouldn't it? So the whole point of the fraud proof is to make sure that when that checkpoint is posted, that is actually correct and does what it says on the tin. So a challenger could come along. The challenger could be a troll, or it could be an honest user called Alice who wants to protect the system. From the system's perspective, they don't know if the challenger is a troll or an honest party. But regardless of the challenger can come along and say, oh, executor, I don't like your checkpoint. It looks sus. I'm ready to play this game and prove that is wrong. And of course, the executor's a bit like, ugh, now I've got to do this challenge game. So now there's this challenge game that happens on chain. They go back and forth, and eventually they'll get to a single execution step that they disagree on. And the execution step is so small that it can be executed on Ethereum directly. then Ethereum can say, okay, given the challenge game between the challenger and the executor, we eventually get to the point where we say, oh, here's the disagreement, execute, oh, here's the winner. I now know who is at fault and who was honest and correct. And in this game, the executor wins, the challenger loses, and the executor was the honest party, and they were doing the right thing. So they were just being trolled by the challenger. And that's how fraud proofs work in a nutshell. And that's the idea that as long as there's one honest challenger out there, there could be anyone in this room, hopefully, you could step up, stake your funds, and defend the system against a malicious operator. And that's what makes rollup so special. I mean, there's only two parties. You don't need 100,000 validators. You need someone to run the system and anyone to protect the system. So that's where Bold comes in. Bold is a new fraud-proof system. So in 2021, Arbitrum was launched with fraud proofs, but the fraud proofs had, they worked, but there's some theoretical parts of it where you're like, this could be much better. And so over the past 2 years, at least at Off-Chain Labs, they worked on this new protocol called Bold that solved some of the theoretical problems around how they designed fraud proofs initially. And I have some little points to make there. There's something called an exhaustion attack that I won't go into now, but there's a solution to this in Bold. That challenge game, that bisection protocol, it's a lot shorter. In the initial fraud proof system, it was quite a long game. It could be extended indefinitely. Here, it's very short. It can only last up to 2 weeks. So eventually, it'll always finish. And it's also a team-based game. If Alice is fighting Bob, then Alice goes offline. Then Caroline could pop up and continue the game and protect the system. So for most people, you don't really have to be concerned about that. But Bold is just a better fraud-proof system in every single way than the existing system. And there's 2 proposals in the DAO now. The first proposal, and actually this is important because the DAO has 2 missions. The purpose of the DAO is 1, the DAO is the ultimate defender of the protocol, and the DAO is in charge of all upgrades to the protocol as well. It's the least fun part of the job, but is the main part of the job. The second one is the DAO has a treasury, as you all know. You can submit a proposal, get funding, and go kick ass and have fun. So this talk is really about that first part, defending the protocol. And here the DAO can decide if they're going to adopt this new fraud-proof system. There's a second proposal to bootstrap the first validator. So in a fraud-proof system, we rely on stake. So you have to stake some funds, have skin in the game, and then participate in it. So hopefully with this proposal, at least the Arbitrum Foundation can be bootstrapped, and we can be the first actor to protect the system. But it's openless, permissionless, and anyone could stake funds and also protect the system as well. The second technology is Stylus. So I just want to ask 2 questions here. Who is a Solidity developer? Raise your hand if you've ever used Solidity. Some people over there. And any Rust developers? Okay, no one likes Stylus then. There's no Rust developers. I'm joking. So the whole thing about Stylus is that the goal is to have the EVM, Solidity smart contracts, remain as is and unchanged. So with this upgrade, there will be no impact or no change to Solidity or the EVM at all. They will run exactly the same. And with Stylus, all it really does is it creates a bridge from the EVM, which is a virtual machine, to a WASM virtual machine. And WASM is like WebAssembly, so this is a well-known, well-used, very competent virtual machine. So it creates a little bridge to WASM, where now developers can create Rust smart contracts or C++ smart contracts. And those smart contracts can be first-class citizens on Arbitrum. So if you have someone over there who develops Rust, and they create a Rust smart contract, it can be interruptible and communicate with any Solidity smart contract as well. So what's really nice is that if no one likes WASM and no one likes Rust, then this EVM world can just keep building up and grow as big as it is today. But if someone does like Rust, they can start developing Rust programs, developing Rust smart contracts. And this little ecosystem can grow. So it's purely additive, I think that's the correct word, additive, I can't really pronounce it, to the execution environment. So it's really cool. And also, as WASM, I don't know if you know about the history of the EVM. It was sort of developed in 3 months as a proof of concept, and now we're stuck with it. or at least the WASM's like a dedicated compiler or a virtual machine that's very fast and performant, and so you can bring the execution costs right down because it's actually made to be a proper virtual machine. Although I do love the EVM, I'm a first class I'm a Solidity developer. That's the best way to describe it. So I do love the EVM, but I'm glad that we can now have WASM, and that's what Stylus is about. And there's two proposals. One, does the DAO want to adopt Stylus in Arbitrum 1 and Nova? Again, it's up to the DAO to integrate this to the network. And actually, there's a to-do. Because if the DAO adopts Stylus, then it'd be really cool to have proposals about Stylus, really focus on dev rails and getting developers up to speed on how to implement and use Stylus in their smart contracts. Now, really close to my heart, and what gets me really excited about rollups is that rollups are a tech stack. So I'll ask one question to the room. Do you know of any cryptocurrency exchanges or cryptocurrency services that have lost user funds? Raise your hand if you're aware of that. Look at this, of course. We're all being rugged all the time. So the problem there is that for the past 14 years, we've been building these cryptocurrency services with Web 2 technologies that are not fit for purpose to protect or interact with crypto assets. You essentially end up with a single private key on a server, and if the hackers get in, they steal that key and they steal all the funds on the service. And it's been, back when I started many years ago, there was an exchange hacked every 2 weeks. Today, it's much better. They don't get hacked as frequently. Maybe it's once a month. But I'm just joking. But it's much better now than it used to be. But rollups are a good tech stack to solve that problem. So now there's this meme that I really like. Rollup is the new server. If you're going to create a third-party service that interacts with crypto assets, you can take a rollup as a tech stack, deploy it, build your application there, and get all the nice benefits of the tech, of something like Arbitrum. You can deploy a service, issue a game to the users, but never be responsible for protecting their funds. That's great. And as a user, I can interact with an operator, and I don't have to trust them with my money either. I lock it in, I play the game, I get my funds back out, and I never trust the operator. That's great. So the Arbitrum expansion program, or Arbitrum Orbit, is really just about saying we have Arbitrum, the tech stack, we have Arbitrum 1, Arbitrum Nova. The tech stack's been running live for a couple of years, we've bottle tested it, and we know that it works. So now can we get other people to adopt the tech stack for their applications? And so it sort of reminds me of this old quote. I used to work at IBM. I was an intern at IBM for a year. There's this old quote by Thomas Watson in 1943. I think there was a world market for maybe 5 computers. And of course, in hindsight, that's really dumb, isn't it? Because this is a computer right over there. So there's like millions of computers. And it's the same for rollups. Maybe 2 years ago, there were 5 rollups. If you go on the L2Beat website today, there's about 40 to 50 rollups. And I know in Arbitrum, at least in terms of people adopting the Orbit stack, there's around 50 teams that are currently in the works of trying to adopt an Orbit stack for their own application. So I suspect in a few years' time, we'll have hundreds of rollups, maybe thousands. I hope there's thousands anyway. I'm sick of people being rugged. So yeah, that's the Orbit strategy anyway. And I made this slide actually back in 2019, and this is how I've always seen the world evolving for rollups. You have Coinbase, Bitstamp, Binance, custodial services, relying on cryptocurrencies, and they're really just moving to a world where they're changing the tech stack from their Web 2 stack to a rollup stack. And Coinbase is a great example, because Coinbase now has Base. They're using the Optimism stack, but they're still using a rollup stack to protect their users. So it's really great to see companies realize that this tech stack can protect their users and to adopt it. And of course, as I mentioned, there's this whole ecosystem now of Orbit. And there's one proposal on the forum today. So right now with the software license for Orbit, you can only deploy an Orbit chain or use the Arbitrum tech stack if it's deployed on Ethereum or a chain that derives security from Ethereum. So there's a proposal on the forum. They asked the DAO, should we expand the license so you can deploy your Orbit tech stack on any blockchain? So it could be launched on Bitcoin, could be launched on any EVM chain, or it can be launched on Solana if you want, whatever floats your boat. So it's really up to the DAO to decide if they want to allow that, or still constrain it to just EVM chains. And hopefully there'll be a snapshot vote very soon to decide if that license should expand. And another to-do is, I think there was like a track for it here as well. Yeah, there is for Orbit. It'd be really cool to see the DAO work on initiatives to help with Orbit adoption and to really get this tech stack into the hands of the right devs and really just protect users, because that's what rollups are about. And then finally, time boost. So this one's a bit more quirky. The other three are a bit more general, easy to understand. Time boost is a very specific tech or upgrade. Hopefully I'll explain it through a story. So what we care about in time boost is how does the sequencer decide how to order transactions? What is the transaction ordering policy for deciding, transaction 1, transaction 2, transaction 3? So most rollups today implement first come, first serve. And what does that mean? It's very straightforward. The ordering algorithm is the following. I get the user's transaction, I timestamp it, then I order transactions according to their timestamp. So if the transaction came in first, is at the top of the list, and if the transaction came in last, is at the bottom of the list. First come, first serve, very straightforward way to order transactions. Now, what was really nice about first come, first serve about 2-3 years ago, actually, who's familiar with MEV? Okay, so MEV is just a way to extract value from user transactions. So first come, first serve is advertised as like the holy grail of saying, oh, we can now defeat MEV. And there'll be no MEV in our chain because we trust the sequencer not to extract value. It's first come, first serve, so there's no way you're going to extract value. There's no MEV. That was like, the paradigm shift. Now, as part of first come, first serve, or just a rollup infrastructure in general, there's typically a sequencer feed. So the idea of the sequencer feed is that third-party providers like Coinbase, Etherscan, and Fura, they can connect to the sequencer and hear about recent blocks. So as a user, you send your transaction in Arbitrum, you can then immediately look at Etherscan, and you can see that your transaction was confirmed. So there's this API to provide the most recent blocks to the third-party providers, just so users can have up-to-date info. Well, if there's a sequencer feed with recent blocks and transactions, well, at least in Arbitrum it's only blocks, what if an MEV bot listens to it? An MEV bot's like, oh, I can find the latest the latest blocks. If I find the latest blocks, maybe I'll find a back-running opportunity, where a wheel swings the price, then a bot connects and swings the price back, and then collects profit from doing that. Well, a wild searcher did appear. They started listening to the blocks, and now it becomes a latency game. Whoever hears the block first, and whoever finds the back-running opportunity first, will then get the opportunity and collect the profit. So if one searcher appears, a lot of searchers appear. And so Arbitrum ended up having 150,000 WebSocket connections because all these MEV bots were trying to find their back-running opportunity. And you can imagine that's like a denial of service attack on the infrastructure. Poor DevOps team. They're the ones who have to deal with this. So the initial proposal to solve this was last year. Well, why don't we do hashcash or proof of work? Get the Bitcoin miners back in to decide who gets to hear the block first. I thought it was a really fun solution. The community hated it because people don't like proof of work. So it never really got built or deployed. But I thought it was really fun. But this is like a funny story. The sequencer did everything right. The sequencer is fully trusted, will not extract MEV, will protect the users. And I don't know if you know Phil. He's the guy who discovered MEV. The dark forest is always lurking and always ready to extract value from their users. Really annoying. You give one, a carrot, and they eat your hand. So this brings up the question, what is fair? Should we still allow these latency games to occur? Or could we have an auction system instead? If there's an auction system, then the MEV bots have to bid for the right, and maybe we can extract some of the value back to the ecosystem. So Time Boost takes the auction approach. It basically admits that these latency games will always exist, so why not have an auction? Why not try to get some value back to the community, if it's going to happen anyway? And at least for backrunning is mostly a positive form of MEV. It's good MEV. So the idea came up last year on a forum post from Ed. They obviously have an academic paper now. They've implemented it. And it works as follows. You have the sequencer feed. And then basically the MEV bots can buy the right to an express lane where they hear the blocks before everyone else. So I think they hear the blocks, or they can send a transaction and they get like a head start on everyone else. And there's only like a 200 millisecond advantage. But if they play the auction and they win the auction, they get on the express lane, and so then you remove the latency game. And that's it. That's all Time Boost is. Replaces latency games with this auction and offers an express lane to the person willing to pay for it. And bam. That's Time Boost. And now there's a proposal on the forum asking the DAO, should we adopt Time Boost as a way to fight latency games? And hopefully it brings some value back to the DAO. And that's my last slide. So I hope you enjoyed it, and hopefully explains some of the tech. Cool.
I think we might have some questions, although you probably answered a lot of questions. You did for me anyway.
Hey, Patrick. How's it going? I was wondering if you could speak at all to any details on how the auction works. Like, is there like a minimum, is there like a price floor, or if no one bids, you know, will there just be no auction? Do we expect there to be cases where no one actually bothered, like there isn't any economic value associated with being first? Just like any more detail about
So
how the auction works and how we expect it to perform in Time Boost.
So to the best of my knowledge, the following features exist. So the auction is an on-chain smart contract. So if you're an MEV bot, you'll create a bid, you'll send it to the sequencer, then that bid will be submitted to a smart contract, and that's how the funds get distributed. And that's how you also gain the right to the express lane. It's a second price auction. So all the MEV bots will place a bid at the start of the round, and whoever's the highest bid will then pay the second price of the second bid. So always two bids are submitted to the auction smart contract. And there's also a reserve price in the smart contract. So the bid at least has to be a minimum. You know, you can imagine it at least has to be at least $1. If they bid 50 cents, then it's not a valid bid, and they don't gain rights to the express lane. I think, you know, in MEV world, MEV bots will be willing to bid up to the amount or close to the amount of the value they're going to extract alongside. And also in this here world, there's one problem in MEV, at least historically, was if you're trying to extract an opportunity, you would send a transaction, and then your transaction would fail, but you have to pay for the gas fees anyway. And that turned it into a probabilistic game where it's like, well, sometimes I'll fail, sometimes I'll win, and that'll, you know, impact my bid. In something like Time Boost, everything's off-chain, just between the sequencer and the MEV bots, so there's no chance of failure. So in that case, you know, it makes it much, for the bot at least, it's much easier to predict, okay, well, if I bid this, well, you know, I'm not going to lose any money, because if I don't win, I don't win. So they'll typically bid close to what they're willing to, or what they're expecting to extract in terms of MEV. So you would like to think the bids would be meaningful. And I guess in the case that, although I'd have to double check this, if there's no bids for the auction, then no one gains the right to the express lane. So and then again, you just end up in a latency game anyway. So really you'd want to make sure the bids are, you know, if the auction doesn't work, you're going to end up with latency games. So you're just going to default to the worst case. So it doesn't change anything, just hopefully they actually do use the auction system. So hopefully that helps answer the question.
Thanks. Cheers.
Will the, so technically the auction contract is also another D-app on top of the Arbitrum, right? So the ordering of that auction should be first come, first serve, I assume? And
the auction will happen between the sequencer and the MEV bots, and then the sequencer will take the two largest bids and then submit that to the smart contract. So
it's off-chain. Okay, it's off-chain. Okay.
Yeah, off-chain, yeah. Exactly.
Off-chain, so there's no kind of spamming or risk conditions. Okay, got it, thank you.
Is there going to be a delay in the block time on Arbitrum 1 if Time Boost is implemented?
So there could be so MEV bots will use the express lane for submitting transactions, and they get a 200 millisecond head start, where normal users will then have a 200 millisecond disadvantage. But every block's 250 milliseconds anyway. So really, in the worst case, you'll miss one block, and you'll end up within the next block. So it should have minimal impact on the user experience. As in, like, 200 seconds for the MEV bot, 50 milliseconds for the user. But obviously, if you send your transaction here, you're going to end up here. So users shouldn't have a real, you know, it shouldn't impact their experience. or at least very minimally.
All right, let's have a big hand for Patrick. Thank you.